thank you for joining me today. My name is Mihir, and I'll be walking you through a very basic concept in the super crazy, wacky, and fun science of chemistry called molarity. By the end of this video, you will be able to understand the definition and application of this concept called molarity, identify and understand the components of molarity, memorize the molarity formula, and solve for molarity. Alright, so 4 really easy objectives. At any time in the video, feel free to pause, rewind, in case you missed something, need to write down something, need to revise. There will be times where I recommend you pause during problems to take your time and work through them, reflect. By the end of the video, you'll be able to solve for molarity, and good luck. So by now you're probably wondering, what is this molarity he's talking about? Well, maybe I should have started with that, but really, molarity is a really simple concept. Molarity is just really a fancy word for concentration of a substance. And basically, in chemistry, we use this term to signify the multiple components of molarity or concentration, which we'll talk about a little later into one word. So if I'm given a problem and it has multiple components and I need to find the concentration, molarity is basically the way to say, okay, molarity is this and that together to find the concentration. Okay, so by now I've probably really confused you, but think of it this way. Molarity is 2 parts, and those 2 parts are called moles and liters, alright? So now you're probably going to be more familiar with the word liter, right? Liter is basically your volume, and you could think of liters as like a 2-liter soda bottle, or a 1-liter pack of any drink, and drinks are going to be the most common thing when we think of liters, or volume. Alright, so liters are going to be our volume, right? And the second part is moles. Second part of molarity is moles, and you may have not heard this before, maybe from basic chem. But basically, a mole is a unit of a substance that is equal to 12 grams of carbon 12. So carbon 12 is just a way of saying 12 grams of carbon, and that's basically what a mole is. So everything around a mole is revolved around these units. In more complex chem problems, you'll be able to find the number of moles starting with like grams of a substance or atoms of a substance, but for now, because we're doing basic molarity problems, we're going to be given the number of moles, so we can plug it right into our formula, which we'll talk about next. Okay, so now we know molarity is basically concentration, which has 2 parts, moles and liters. So now we get to find out how do we put moles and liters together to find molarity, and it's a really simple formula. So the formula is going to go like this. Molarity, which is in units of m, capital M, or molars, is equal to the moles of a substance over the liters. Bam! Easy like that. Moles over liters. So super easy. We're going to try one problem right now to see if we can find the components of molarity, put them together. Just remember, moles over liters for easy reference. So the problem states a chemistry student is mixing a solution of HCl, hydrochloric acid. He wants to make 6 liters of solution, and he has 0.0288 moles of HCl. What would be the molarity of the 6-liter solution? So first, the first thing we want to do is we want to write down our molarity formula, which we know is M, which is molarity, is equal to moles over liters. Okay, now we want to identify our components. So we need moles and we need liters. So right off the bat, you're going to notice it says he wants to make 6-liter solution. And it's going to ask what would the molarity be in a 6-liter solution. So for our volume, we know that we need to find the molarity of a 6-liter solution. It's asking us right there in our question. So our volume is going to equal, or liters, 6 liters. And then moles, it gives right here, it says 0.0288 moles. So we know moles is going to be 0.0288, and now we just plug it into our formula. So we know that molarity is going to equal 0.0288 moles. Wrong unit there. Over 6 liters. And all I have to do is plug this into a calculator. 0.0288 divided by 6. And right here, I've already plugged that into my calculator, and I know that's going to equal 0.0048 molar. So that is going to be my molarity. Just like that. Quick, easy. Let's try one more, and then we're going to see if you can do it yourself. Alright, so now we're going to try our second practice problem. And this one's going to be a little bit trickier, because the problem's going to try to trick you. So let's read it first. It says, there are 655 milliliters, okay, of HPO4 plus phosphoric acid. Just ignore that, right? We just want to focus on that. And there are 1.25 moles, I'm just marking it up this time while we read, of the solution. Determine its concentration in units of m, which is equal to molar. Okay, so this problem's going to try to trick you two places. We know our molarity formula is m is equal to mole over liters, moles over liters, mole. Keep making this mistake. And then we want liters, right? But we've seen the problem, it gives us milliliters. So the problem's trying to trick us. Your instinct is going to be to plug this in, but you're going to be confused because you see liters and milliliters. What we want to do is every time we're given a volume, whether it's milliliters, any volume at all, we want to make sure it's in the standard unit of liters. So to get to ml, 100 ml is equal to 1 liter, making this, you just move the decimal place 3 places over, basic math, 0.655 ml. So now we know that. And the second place this problem's going to try to trick you is right here in this part right here where it's asking for concentration. Remember, concentration just equals molarity, and we also know that our unit of molar is for molarity. So we know we're finding molarity, we know our molarity formula, we know our volume that we've converted it, and we know the number of moles. Right here it's given straight out to us. So now we have our value for moles, we have our value for liters, we plug it into our molarity formula, which is equal to moles over liters, and we plug in our values. I've already put it into my calculator, and I know that my molarity is going to come out to 1.908 molar, which is my molarity value. See? And at this point, we're going to move on to our assessment problem next. If you're struggling, go back, watch me do it again, watch me explain the concept, and if you're ready to move on, let's move on. Once I give the assessment problem, I will recommend pausing the video so you can work through it on your own, see if you understand it, and then check your answer, and then go back if you don't understand it. So, that's it. Let's do our challenge problem. Okay, so here is the dreaded self-assessment, or self-assessing problem, which you'll do and find out if you really understand how to solve for molarity. And it's a really easy concept, so I think you'll be able to. So what I recommend now is after I read the problem, please pause the video, take as much time as you need to calculate for molarity, and then unpause and check your answer with my work, and you'll find out if you know how to do it or if you don't know how to do it. So the problem is, there is a solution, AB, made up of 175 milliliters of solution A and 225 milliliters of solution B. Find the concentration of solution AB in molars, or m, if it is 3.5 moles. So solution AB is made up of solution A, solution B. Find the molarity. So at this point, I'm going to recommend you pause and solve the problem. Good luck. Okay, so at this point, if you're here, you've either attempted or solved the problem after pausing the video, and I'm going to go through it now, so you'll see if you're right or if you're wrong. Okay, so what we need to know is that there's a solution AB made up of 175 milliliters of solution A, 225 milliliters of solution B. So the volume of solution. So the way you go about this problem is going to be, you see that you have solution AB, and you see that it is made up of 175 milliliters of solution A and 225 milliliters of solution B. And it's asking for the concentration in molar, which we know for two reasons. It's going to be molarity. We know molarity equals concentration, and we know molar is the unit for molarity. So we know that we need to find the molarity, which is all we've been doing. And right here it says how much of this volume combined in liters with this much moles, how much is the molarity of solution AB? So it's a little bit funkily worded, but find the concentration of solution AB in molar if it is 3.5 moles. So here we have a molarity formula right here. We know our liters by adding 175 plus 225, and we get 400 milliliters. We're going to convert that into liters by dividing by 100. The simple conversion, we know that 1 liter is equal to 100 milliliters. And what we're going to do from there is we know our volume, so we're going to plug that into our molarity formula. So we have 4 liters, and then we know that we have 3.5 moles, so we put 3.5 moles at the top. Then we go into our calculator and we enter 3.5 moles over 4 liters, and we're going to get a value, and that will be our molarity because it's the result of our moles over liters, which is our molarity formula. Basically, find moles, find liters by combining and then converting units, and then your moles is given, and divide them, and you get your molarity. Molarity is concentration. So if you were able to solve this, that means that you have fully understood molarity, and you are now on the first step of becoming a super awesome chemist. If you did not get this, I'd recommend going back into the video, watching the examples again, and then coming back and trying this problem. And now that you've seen how it works, you'll understand it better. And to really challenge yourself and go above and beyond, going online looking for basic molarity problems will really help you advance in this concept, which has a lot more depth to it. But now that you understand basic molarity, you're on your first step towards being a super chemist.